All right, so tonight you are doing, this is 7-5, and today is 12-11. Oh, forget that. You are doing page 389. Whoops. Page 389. And it is 1 through 25 odd. Okay, questions? All right. So the first thing I'd like you to do, I'm going to make this cross here, and I call this X marks the spot. So when I talk about X marks the spot, this is what I mean. Now, what I want to know is what two numbers multiply to 39 and add to 16? What two numbers multiply to 39 and add to 16? Jada. 13 times 3. How did you get that? Huh? Did anybody else get that? How did you get it, John? Explain your thinking.
So, when you're saying it multiplies to 39, the only thing that multiplies to 39 is 3 and 13 besides 3 and 39. So, this 3 and 13, so multiply them together, you have 39, and then add this together, you have 16.
Okay, Chris, what's your thinking on that?
You can just find all the factors for 39.
Why would I not find the add-ins for 16?
There are infinite add-ins.
There's a lot of add-ins. So there aren't infinite amount of products. So we always take the product and say, what are the products? Well, I know it's 1 and 39. 2 doesn't go. 3 doesn't go. 3 goes, and it's 13. I'm going to keep going until I hit 13. 4 doesn't go. 5, it doesn't end in 0 or 5. 6 doesn't go into it. 7, no. 8 times 5 is 40, so nothing goes into 39. 9, looks like it might, but no. 10 doesn't go. 11 doesn't go. 12 doesn't go. But 13 goes, okay, it's time to stop. That's the thinking that goes on in my head. Okay? Now, since what I'm looking for is two of those factors that add or subtract to 16. Yes?
Can you just stop at 3 times?
I'm just saying if you had a number and when do you stop normally? If you know there's no more, Daniel, it's going to be much faster and you're not going to have to make that. If you know that's the answer, of course you stop. But I'm saying in general. Does that make sense? Okay, so now let's try another one. Okay, so now let's look at what two numbers multiply. Here we go. What two numbers multiply to negative 12 and add to 1? Whoops. Let's go with Willie.
Alright, to multiply to negative 12 will be negative 4 and 3.
Negative 4, positive 3. Now check yourself, Willie. Does that make negative 12?
Oh, no, it's 4 negative.
So it's positive 4 and negative 3. All right? Okay, what about the next one? Daniel Ledvin.
It's negative 2 times negative 2.
Times negative 2. We good? Does that multiply to positive 4 and add to negative 4? Who's confused? Okay, Nicole. What two numbers multiply to negative 4? Again, if I really just make a, what are the factors of 4? I don't do any signs. 1 and 4, 2 and 2. Now, I play with the signs afterwards. What two factors will multiply to negative 4 and add or subtract to 0? It's her turn, not yours. Well, does that add? Okay. You only have another pair of -2, -2. Does that multiply to Ah. So does that multiply to negative 4? Does that add or subtract to 0? Yep, the sum is 0, so that works. Okay, next two, why don't you guys try on your own? Go. Pause the recording. Okay, now check your work. So we noticed that negative 2 and 12 work for 24 and 10. And negative 3 and 14 work for negative 42 and 11. All right, can we move on, or do you feel like you need to practice it a little more? Okay, anybody who's still confused, I can be here for like 10 minutes right after school if you want to start your homework then. Okay. So, a GCF. A GCF is a greatest common factor. So if I asked you the greatest common factor between like 24 and 30, if I break down this to prime factors, just listen for a minute, put your hand down. If I break it down to prime factors, 24 is made up of 2 times 12. 12 is made up of 2 times 6. 6 is made up of 2 times 3. Does that equal 24? And they're all prime, right? 30 is 2 times 15. 15 is made up of 5 times 3. So my GCF is what they have, the factors they have in common. I have a pair of 2s. I have a pair of 3s. And that's it. When you multiply them together, what is it? 6. 6 is the greatest common factor of 24 and 30. Does this make sense?
Yes.
So I'm going to ask you the same things. What is the greatest numerical factor of 15 and 12? Jairus, 3. So I'm looking at, and I know that 3 is my greatest numerical factor. It divides into both. What's the greatest amount of x's I can divide out of x squared and x that they both have in common? Platy?
X.
Just an x. One x, not two x's, because this one doesn't contain two x's. Okay, what's the greatest amount of y's I can divide out of each term? Gabby?
Y.
Just one y. And so what we have here is called the greatest common factor. Understand? No, I don't understand? Okay, Nicole, what's the greatest numerical factor here? Out of 30 and 42, what's the greatest common numerical factor that divides into both? 6. What's the greatest amount of a's I can divide out? Don't say 2, say a squared. Okay? What's the greatest amount of b's, Hike? 1. Don't say 1, say b. B to the first. So this then becomes our greatest common factor. Okay, pause the recording and find the GCF for number 3. Okay, numerically, what's the greatest common factor?
7.
Okay, and what about m's, Andranik? Greatest amount of m's we can divide out.
4.
M to the 4th. Greatest amount of n's I can divide out. Jasmine?
2.
How do you say it? Good. And so this is my GCF. Are we good?
Yes.
Caleb?
I'm just so confused how you get the variable to whatever how it is.
Okay, so I'm going to erase this right here. If I were to expand 14, right? If I were to expand 14m to the fourth n cubed. And 21m to the fifth, and it's n squared. Okay, if we expand that into prime factors, let's just look at the variables. Forget about the numbers. This means m times m, or here, I'll just put here. 2 times 7, right? 4 m's, 2, 3, 4. And 3 n's, 1, 2, 3. The next one is 3, 7, m, 2, 3, 4, 5, and 2 n's. Now, if I'm trying to find greatest common factors, the greatest amount they both contain. Here's a pair. Here's a pair of m's. Here's a pair of m's. Here's a pair of m's. Any other pairs of m's? So what would we call that? M to the fourth. It's the smaller amount of the two. It's what they both contain. This carries n squared. And we said they also had a pair of 7s. So 7. Okay, does that make sense, guys? Okay. Moving on to the next part. All right, so I'm missing a factor here. Just like if I had 6 equals 2 times something, what would I put in there?
3.
3, right? Okay, what factor is missing, Caleb, for number 1?
X to the 6.
X to the 6, good. What factor is missing for number 2, please? Hike.
4, 8 to the 3rd.
Perfect. What factor is missing, gyrus? 2xy. Nicole, what factor is missing?
4,
A squared. B to the 3rd. A squared, it'd be 4a squared b to the 3rd power. Okay, next one, Andranik.
-7 x to the 3rd.
Uh-huh.
Y.
Okay. Next one, number 6. Well, let's go with Willie.
-2h to h and k to the 2nd.
Good. -2hk squared. Questions? Okay, moving on. Now, when we factor polynomials, you don't need to write this down for time purposes. Let's hold off on writing this down because it's a little bit out of order. There are 5 different ways that we can factor. And we combine greatest monomial factoring with everything. So every time I factor, the first thing I'm going to look for is a greatest monomial factor. So here's what we do. The greatest monomial factor is a greatest common factor. I want to know what is the greatest common factor of both of those terms. Numerically, what's the greatest common factor? Chris?
The greatest common factor numerically would be
2. And what's the greatest amount of m's I can divide out of both? Caleb?
M to the 3rd.
Good. And what's the greatest? Oh, that's it.
Yeah.
Okay, so now I've got to draw my parenthesis. And what's left out of this? John?
6m.
So when I divide 12 by 2, I'm left with a 6. When I divide m to the 4th by m to the 3rd, I'm left with 6m.
Minus.
And when I divide 10 by 2, what's left?
-5.
And m to the 3rd by m to the 3rd, it equals 1. And 1 times 5 is 5. So this is what we call factoring. Have you seen it before? I'm going to take a little sidebar and just do another little example. If I have something like this, what does that simplify to? Ian?
5x plus 10.
5x plus 10. But if I have 5x plus 10 and I ask you to factor, what's the greatest common factor? Kate? 5. And what's left when I divide a 5 out of each term? Okay? So all factoring is the reverse of the distributive property. Does that make sense? All you're doing every time is pulling out the GCF and listing what's also left. If you only give me this, it will be wrong. If you only write down 5, I say factor, and you give me 5, it'd be wrong. Because whatever you're factoring should equal what you start with. Does 5 equal 5x plus 10?
No.
So you've got to factor, and you've got to factor completely. You got to use the greatest common. All right. So we said number 1 is, okay, what is the GCF of number 2, please? GCF of number 2. Zach Smith.
5x.
Number 2, you're on 3.
7.
7A. So when I factor the 7A, what's left inside the parentheses, Zach? When I divide the 7 out of the 14, what's left? When I divide A squared by A, what's left? If I take one A out, how many are left? Yes, if it's A squared and you take 1 out, you're left with an A. Now, Zach, when I divide, remember, 7A, another way to look at it is, hold on, let me go back so I can get rid of this. Another way to look at it is, you said the GCF is 7A. So I'm dividing by 7A, dividing by 7A. What's left inside? We said 2, and I'm left with an A. What's left minus what, Zach? Minus 1. Any number over itself equals 1. Questions? Number 3. Kate.
5x.
5x. I can't take any more than 1x. Okay. What's left when I divide the first one?
3x squared.
Good. Okay, hold on. Nicole, when I divide this middle term by 5x, negative 4x. When I divide this one, let's go with Gabby,
Plus 6.
plus 6. Are you guys good? Understanding? Yes.
How did you get 2a? Like the a?
Because when I divide 14 by 7, what's left? 2. A squared divided by A is A. Okay? Last one, what's the GCF? Caleb?
4.
4. And what's the greatest amount of x's?
X to the 4th.
Okay, I have 4. What?
The least is x to the 3rd versus.
Okay, well, but you tell me.
Oh, x to the 3rd.
Okay, x to the 3rd. And what's the greatest amount of y's I can divide out?
Y squared.
Y squared. Now, what's left when I divide this whole thing by that?
2x. 2xy.
Just
no, 2x.
2x. Minus, what happens here?
3y.
3. X cubed, they cancel, and I'm left with a y. And then the last one, Chris?
5xy to the 3rd.
Plus or minus?
Minus.
5xy to the third. Is that what you said?
Yes.
Okay, there you go. And notice I need the whole thing together. Questions? Yes.
Doesn't this have to be just y? Or 4x to the power of y.
No, because the greatest amount that we can take out is 2 here, and this they all contain 2. That's the greatest amount I can take out of all 3. So it should be squared. All right, so now we're going to learn to factor. When you have this is the reverse. I asked you to double distribute, and what do we get? Ian?
X squared plus 5x plus 6.
X squared plus 5x plus 6. Now remember earlier I asked you to do X marks the spot, and it gave you something like this. Okay, and what do we have that multiplies to 6 but adds to 5? Daniel? 3 and 2. So what we were actually doing was getting ready to factor. When you factor, you're given something like this. And we say to ourselves, what times itself equals x squared? Caleb?
X?
X does not equal x squared.
No, x times itself.
Okay, x times itself. So I would place, how do I factor that? I place, what's the square root of that? I take x times x gives me that. Okay, and then, because these are both positive, I ask you, remember we put the product up here? And the sum or difference goes down here? And you told me that plus 3 and plus 2, and there it is factored. Plus 3, positive 3 and positive 2, multiply to 6, but add to 5. Okay, questions? Yes, Andranik.
For the sum, could it ever be
A difference?
no, saying x squared?
No, not for the sum. All right, now, let's try it again. Only this time. And whenever you're factoring, I want to see your X marks a spot for now. Okay, what number goes in the top? What number goes up top? Andranik? 10. Remember, it's the last term, and we're looking for a product. Maybe you need to write this for your notes. And what goes on the bottom? Hike?
7.
Or the middle coefficient, and it's the sum. Okay, so I'm putting 7 here. What two numbers multiply to 10 but add to 7? Platy?
5 and 2.
5 and 2. Now, what am I placing right here on both binomials? Zach?
X.
X times X. And then what goes here? How about Tony?
Plus 5.
Plus 5 plus 2. Okay. I could also go plus 2 plus 5. Does it matter if I do 2 times 3 or 3 times 2?
No.
So it doesn't matter which binomial comes first. Gabby,
3 and 4.
does 3 and 4 adds to 7, but does that multiply to 10? So it has to satisfy both. Okay, questions? Okay, so every time I'm writing my X marks the spot. What goes up top, please? Somebody I haven't heard from. Josh. What goes in the top? 20. And in the bottom? Okay, and what two numbers multiply to 20 but add to 9? Gohar? Let me guess, Gohar. 5 and 4. And so what would it factor to, Josh? What goes here? Okay. Is that a positive 4 or negative? Okay, so what do I fill in? So, when I ask you what is it factored to, you say x plus 5 times x plus 4. That's the answer. Okay. What goes on top, please, Audrey?
12.
What goes on the bottom, please, Theora?
8.
What kind of 8?
Negative 8.
Negative 8. You need signs matter. What two numbers, Deja, multiply to 12 but add to negative 8? Don't forget, just make a factor tower. Who did I just call on? Deja? So which two add or subtract to negative 8? Okay, 6 and 2. How do I make that happen? I need you to talk a little louder. Negative 2. Does negative 2 positive 6 make 8? Negative 2, negative 6. Okay? Negative 2, negative 6.
So on the board we have to show that x.
I want to see the x for now. Okay? So what is my answer? Deja? Y minus 2 times the quantity minus 6. Okay, questions? Try the next one on your own. Okay. So now, check your work. What multiplies to 12 and negative 7? We have negative 4, negative 3, and so we get m minus 4 times m minus 3. All right, are we ready to kick it up a notch?
Yes.
Okay, here we go. What's the cook that's always saying to kick it up?
Please.
Huh?
Please.
He's the cook, from New Orleans. Spices everything up. Maybe I can't.
Jordan from Rush Hour 3.
So these should start to come very quickly. Now, sometimes they're not going to come to us so pretty. And like I said, we are always going to start with we're going to look at whatever we're given and see if there's a GCF I can pull out first. Then we begin factoring. We begin one of our other types of factoring. So here's an example. Number 1. Is there a GCF? Is there a GCF? Nicole? 3. So I factor out my 3. And I have what's left inside is x squared. When I divide 3x squared by 3, I get x squared. When I divide 21x by 3, I get 7x. And when I divide 36 by 3, I get 12. Now what I'm noticing is I have a polynomial, a trinomial, that looks like it can be factored. So what multiplies to 12 but adds to 7? Hike? 4 and 3. And so that one little piece inside there, what does it factor to? Hike?
X plus 3 and x plus 4.
And so here is my expression fully factored. Does that make sense? Fully factored. Yes, John?
Wouldn't you have to put the 3 to both of the parentheses?
Nope, it's not plus. It's all one term. It's a number times a number times a number. Absolutely not. If, let's say, I have a 12 and I break it down by 2 and 6, I can say 2 times 3 times 2. Would I do this? Does 2 get multiplied by both to make 6? I mean, to make, would that, if I do 2 times 3, that's 6, and 2 times 2 is 4. 6 times 4 is 24. It's too much. You only multiply it in once. Because this is not, there's no plus sign. It's just a number broken up. Does that make sense, John? Okay. All right. Now this one gets kind of tricky, and I don't think I'm going to cover it now. But let's try some more factoring. As long as we have a minute or so to get through this.
Those tiny factors.
Okay. So these should go very quick, like this. Look how fast I do these. As if it were my multiplication tables. What multiplies to 42 and 13? I'm going to say 6 and 7. So this is x plus 6 times x plus 7. Do you see that? Very fast. So what about the next one? What goes up top, please? Tony? On my x, 21. On the bottom, negative 10. And what two numbers multiply to 21 add to negative 10? Negative 7, negative 3. So what does it factor to?
M minus 7 and M minus 3.
Now, we can always double check, especially on a test. Double distribute back and make sure. I know that these two add to negative 10 and these two multiply to 21. Okay, next. What multiplies to 36 and adds to negative 15? Saffron?
Negative 12, negative 3.
Beautiful. And so it factors how?
Y minus 3 and Y minus 12.
Does it matter that I switched them around? No. Commutative property. All right. Questions? Okay, take a minute, do the next two. Now check your work. You guys are just doing the next two. Oh boy, I skipped that one. Let's do that one. Oh, most overused word. Okay, so let's do number 4 together, guys. Notice my PowerPoint, all they're doing are the factors. So what two factors multiply to 24 but add to 12? Which of those two factor combinations? Nicole? None of them. So if that's the case and none of your factors add to your middle coefficient, we just say not factorable. But it's very overused, guys. Every time you get stuck, don't start using not factorable.